Swastiastu. Today we will discuss about mathematical logic. So, first, let me introduce myself. My name is Ketut Wahyu Krisnayana. My student ID number is 2113 011 026 for the class of Mathematics Education Study Program. So, without further ado, let's get started. Okay, now we will discuss about mathematical logic. Mathematical logic is a branch of mathematics that studies logical thinking to be able to draw a conclusion based on current conditions. So, what is mathematical logic? Why do we study mathematical logic? How, okay. However, understanding mathematical logic helps us understand ambiguity and disagreement. It helps us understand where the disagreement is coming from. It helps us understand whether it comes from different use of mathematical logic or different building blocks. Specifically, learning mathematical logic is to sharpen the logical and analytical skills of students as they are necessary for the understanding and learning of mathematical proofs. Mathematical logic, through is characterized by its symbolic presentation and formal rules. In studying mathematical logic, we will use statements. Before that, we must know which are statements and which are not. Statement. A statement is a sentence that is either true or false. Here I give some examples. Pluto is a planet. This is a statement because we know that Pluto is not a planet, so Pluto is a planet is a false statement. Good morning. Good morning is not a statement because we can't determine its truth or not. All other greetings are also not a statements. Cats are mammals. Cats are mammals is a statement because we can determine its truth. Those are some examples of statements. Then look at the right side. Does it include a statement? Okay, let's check them one by one. 1 plus 1 is 2. That is a statement. And it is true. What about 3x plus 2 equals to 5? Is it a statement? So, it will be true if x equal to 1, but false if x is not equal to 1. So, we can't determine the truth of 3x plus 1 plus 2 equals to 5. This is related to the fact that 3x plus 2 equals to 5 is an open sentence. It contains variables, so it's not a statement. And finally, 2 greater than 5. Of course, this is a statement because we can determine that the truth is 2 is less than 5. So 2 is greater than 5 is false. Now that you know what a statement is, we learn the operators of mathematical logic, which we call logical operator. Look at the slide. Have you ever seen the symbols? Next, we will learn what the use of this symbol is. Okay, the first one is negation. The negation of statement is the opposite of the given mathematical statement. If P is a statement, then the negation of statement P is represented by negation P. The symbol used to represent the negation of statement are the tilde symbols. Okay, look at the example. He is rich. The negation is he is poor or he is rich. Okay, isn't rich doesn't mean poor, right? But poor must be not rich. Okay, there's a little bit difference. The negation of he who is rich is not he who is poor, but in reality, not only are there rich and poor, but there are also those in the middle between rich and poor. In general, we can't use the antonym of a statement, especially in that case. When can we use antonyms? Okay, for the example, in the case of I can play guitar, the negation is I can't play the guitar. Look at the second example. She bought a new bag. Is the negation to buy a second-hand bag? Of course not. The negation is that she didn't buy a new bag because It could be that she didn't even buy it at all. The third example, 3 plus 3 equals to 5. The negation is that 3 plus 3 doesn't equal to 6, maybe. I'm so sorry. Okay, from these examples, you can conclude that if a statement is true, then the negation of a statement is false, and vice versa. So we get that the truth table of negation. Okay, next the conjunction. The conjunction forms a statement by adding two statements with the connector and. The symbol for conjunction is and. The symbol for conjunction, which can be read as and. When two statements P and Q are joined in the statement, the conjunction will be expressed symbolically as P and Q. Okay, look at the example of conjunction. Suppose that he eats pizza and drinks Coke. Which statement is true? The first one, he eats pizza and drinks Coke. That's true because that's exactly the same. The second one, he eats pizza but he doesn't drink Coke. And the third one, he doesn't eat pizza but he drinks Coke. And the fourth, he doesn't eat pizza but he doesn't drink Coke. Since one statement is false, all statements are false. Moreover, in the last one, no statement is true, so the whole statement is false. So the true one is the first one only. Okay, the example number 2. Prime and odd number. 2 is not an odd number. And 9 is not a prime number. 4 is neither. So the one that satisfies prime and odd number is 3 only in this case. Okay, so from the examples we get the following truth table on the right side. Okay, next, disjunction. A disjunction is statement formed by adding two statements with the connector or. The symbol for disjunction is P, which can be read as or. When two statements P and Q are joined in the statement, the disjunction will be expressed symbolically as P or Q. Look at the example. Okay, with the same example, we find the truth value. In this case of disjunction, we only need one statement to justify it. So only the last statement is false because the last statement there's nothing we P or Q is true. Okay. Similarly, in the second example, we get only 4 that doesn't satisfy but prime and that odd numbers. So 4 is false. From this, we can find that the truth table of disjunction as follows on the right slide. Okay, next, implication. An important connective is logical implication. If P, then Q. That's read if P then Q. Okay. So recall, if P then Q means if P is true, then Q is also true. If P is Q means says nothing about what happens if P false and says nothing about causality. It just says that if P is true, Q will also be true. Look at the example. Which one is the true? Okay, look at the second one. We find that the second statement contradicts the given statement because the biology said he should have passed, but he didn't. So the second statement is false. The other statement doesn't directly contradict the given statement, so it will be true. Because we have discussed it before, if P then Q says nothing about what happens if P false. Okay. Looks at the second example. Which part will be false if substituted? Okay, everything is going to be true, right? Because we will not find the case of an element n that is not element of Z, because n is subset of Z. From that example, we get the following truth table on the right slide. Last but not least, B implication. The B implication or B conditional connective P double arrow Q is read P if and only if Q. Intuitively, either both P and Q are true or neither of them. Look at the example. Example 1. Can a triangle be equilateral but the three sides are not equal in the length? Of course not. Can a triangle with equal sides not be an equilateral triangle? That's same as the first one, so the same applies to the second example. Okay, from the example we can deduce the truth table of B implication as follows. Okay, that's all for me. Thank you for your time. Thank you for your attention. Uh, See you later. Om Santi 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 Om.